Good day, everyone. Thank you for attending today's presentation. I am Jung Wei from the Hong Kong University of Science and Technology. Today, I will be presenting our research titled Illuminating the Scene: How Virtual Environments and Learning Modes Shape Film Lighting Mastery in Virtual Reality. This study primarily focuses on the application of virtual reality in film production education, especially how it affects students in mastering film lighting techniques within virtual environments. Our study explores the potential of virtual reality, VR, in film education, particularly in learning film lighting techniques. VR provides students with an immersive learning experience, breaking the limitations of traditional physical classrooms, allowing them to practice repeatedly in virtual environments and simulate various filming scenarios. However, despite the widespread use of VR in education, there has been limited research on how different virtual environments influence student learning, especially in creative fields like film production. Our research aims to achieve two primary objectives: to explore how different virtual environments, e.g. beach, office, baseline studio, affect students' learning of film lighting techniques, to examine the interaction of team-based learning and individual learning modes in these environments. Our research questions is first, how do different types of virtual environments, baseline studio, beach, office, affect students' learning experience and cognitive load in film lighting tasks within cinematography education? Second, is there a difference in the impact of learning modes, team-based learning versus individual learning, on learning outcomes across these virtual environments? In which environments might individual learning outperform team-based learning? Third, how does the interaction between virtual environment design and learning modes affect students' learning performance and satisfaction in film lighting education? In terms of related research, while existing studies have explored the impact of VR on learning, most focus on scientific and technical fields, especially on cognitive load and presence. In the realm of film production, particularly in lighting design and cinematography, research on the impact of VR is relatively limited. Most studies examine learning modes, such as individual versus team-based learning, but few investigate how the design of virtual environments interacts with learning modes to affect learning outcomes in creative fields. Therefore, we aim to fill this gap by experimentally testing how virtual environments and learning modes influence film lighting education. For our research methodology, we designed a 3-2 experimental framework with 3 different virtual environments and 2 learning modes. Virtual environments: baseline studio, a standard virtual film set with minimal distractions, focused on task-oriented learning. Beach environment, a more complex setting with dynamic changes and increased visual stimuli, likely increasing cognitive load. Office environment, a familiar work environment that is somewhat more complex but still manageable. Learning modes: individual learning, participants perform the tasks independently. Team-based learning, 2 participants collaborate to complete the tasks. We recruited 36 participants, all students enrolled in cinematography courses, and they completed 2 tasks. Lighting setup replication task. Participants replicated a lighting setup in the virtual environment based on reference images. Camera shot task. Participants designed and shot a 30-second short film on the theme, Dancing in the Light and Shadow. To support this research, we developed the Film Meta Studio VR filmmaking teaching system. This system provides various lighting devices, e.g. LED, tungsten, daylight lamps, enabling participants to conduct lighting setup experiments. Participants can freely choose props and set designs, and even operate virtual cameras for shooting. Additionally, Film Meta Studio supports multi-user collaboration, allowing team learners to complete tasks in the same virtual environment and engage in real-time discussions and adjustments. The system was designed to help students better understand the principles and practical applications of film lighting.
Film Meta Studio offers a user-friendly interface that helps students focus on mastering film production techniques. When users select any lighting equipment, pressing the trigger button on the left-hand controller automatically brings up the control dashboard, enhancing interaction with lighting settings. The panel provides a range of adjustable parameters. Within the Film Meta Studio system, users have access to 2 types of lighting, allowing learners the freedom to generate their desired light colors. We've standardized controls across both lighting types, enabling adjustments to light intensity, illumination range, and RGB color settings. The virtual panel above the user's left-hand controller features select, move, and rotate buttons, corresponding to object selection, movement, and light angle adjustments. Users can operate the camera in front of them to select the record button for video recording. The footage is saved instantly, allowing students to edit and compile their clips. Upon entering the login screen, users can choose their preferred learning environment. We designed 2 movement modes to streamline user operations. In limited physical spaces, users can adjust direction and teleport to target locations using the remote control function on the left controller. When space is ample, users can set up a safe zone, synchronizing virtual movements with the real world. Additionally, users can toggle the sunlight on or off to observe the effects of their lighting setups.
We propose 3 main hypotheses. Different virtual environments significantly influence students' learning experience and cognitive load. Challenging environments, e.g. the beach, may increase cognitive load and frustration for individual learners, but they can also enhance immersion within the scene. The effectiveness of the learning mode depends on the type of virtual environment. In familiar or less distracting environments, e.g. the baseline or office, team-based learning outperforms individual learning, whereas in challenging environments, e.g. the beach, individual learning may show better results. There is a significant interaction between virtual environment design and learning mode, which affects students' performance and satisfaction. Specifically, team-based learning improves performance and satisfaction in familiar environments, while individual learning in novel or challenging environments may increase engagement and scene perception. In the first task, participants were required to replicate a lighting setup in the virtual environment based on reference images. The evaluation criteria included the accuracy of the setup, the appropriateness of the lighting choice, technical proficiency, and the final visual outcome. We found that in the beach environment, individual learners performed the best, likely because the environment provided more challenges and creative opportunities, even though it resulted in higher cognitive load. In contrast, team-based learners performed better in the baseline studio and office environments, indicating that teamwork helped reduce cognitive load and enhance task performance. The second task required participants to design lighting and camera angles and shoot a 30-second short film on the theme Dancing in the Light and Shadow. Evaluation criteria included thematic execution, creativity, technical execution, and artistic expression. The results showed that individual learners excelled in the beach environment, as they were able to independently exploit the creative potential of the challenging setting. Meanwhile, team-based learners performed better in the baseline studio and office environments, likely because these environments were more suited for collaborative work. Helping to distribute the workload and foster creativity, we used the NASA TLX questionnaire to assess participants' cognitive load. The results showed that individual learners in the beach environment had higher ratings for effort and frustration, suggesting they faced more cognitive challenges. However, they also had higher perceived performance, indicating that the challenging environment stimulated greater engagement and creativity. In the Learning Experience Questionnaire, team-based learners reported higher satisfaction and better learning outcomes in familiar environments, baseline studio and office, while individual learners showed more creative enhancement in the complex environments. Our research demonstrates that the combination of virtual environment design and learning modes significantly affects learning outcomes. Impact of virtual environments. Challenging environments increase cognitive load, but also enhance creativity and engagement. Interaction of learning modes. Team-based learning is more effective in familiar and structured environments, while individual learning thrives in more complex and creative environments. Optimizing learning environments. We recommend optimizing virtual environments based on task requirements and student needs to improve learning outcomes. This research provides valuable insights into virtual reality education. Future research, we suggest exploring more types of virtual environments, testing hybrid learning models, and considering user-centered design. Educational tool design. We advocate for developing VR learning tools that can adapt to student needs, supporting both individual and team-based learning for improved educational outcomes. In conclusion, our study shows that the design of virtual environments and the choice of learning modes are crucial to students' learning outcomes. By optimizing learning environments and arranging learning modes effectively, we can significantly improve students' learning achievements. Future VR educational tools should balance creativity and cognitive load to help students better master complex